Okay, so welcome to another episode of Graham's networking lessons. We'll be working on the JNCIE SP. Today we'll be starting a new topic. So the topic is going to be under device infrastructure still. But it's going to be, instead of automation implementation, it's going to be focused on high availability. So first topic we'll look at is aggregated Ethernet, including fault detection. So I have preloaded up some things I want to look at. So this looks like it's just the regular Ethernet interfaces user guide. I don't see anything about aggregated Ethernet. Here we go. So use this guide to configure, monitor, and troubleshoot the various supported Ethernet interfaces, including aggregated Ethernet interfaces on Juniper Networks routers. You can also configure Ethernet operations, administration, and maintenance, OAM, on Juniper Networks routers to determine how the network of Ethernet links is functioning. So let's skip right down to the aggregated Ethernet section. And then we'll also need to be learning about OAM. So this section here. But so let's have a link for that. And then a link here for this. So these are going to be the two main sections we're going to be working through. Oops, I'm not sure what this was. I'll take a look at it before I just get rid of it. Okay, remote fault detection. So it looks like it's in there. So yeah, this actually has fault detection written in the subject. So I'm going to keep that one. And then just keep track of these two documents here. Perfect. And now I'll get started on aggregated Ethernet interfaces and LACP. You can use Ethernet link aggregation to increase bandwidth and resiliency of Ethernet links by bundling or combining multiple full duplex Ethernet links into a single virtual link. This virtual link interface is known as an aggregated Ethernet interface. This topic provides an overview of the aggregated Ethernet interface and explains how to configure an aggregated Ethernet interface and its various features. So we already know a bit about how to do that. It's going to be, first you got to configure the number of appliances, aggregated Ethernet appliances. Oops, I keep hitting no instead of yes. But we'll definitely be doing an example. So aggregated Ethernet interfaces overview. Link aggregation of Ethernet interfaces is defined in IEEE 802.3 AD standard. The Junos OS implementation of 802.3 AD balances traffic across the member links within an aggregated Ethernet bundle based on the layer 3 information carried in the packets. This implementation uses the same load balancing algorithm used for per flow load balancing. Okay, so this is information about mixed rates and mixed modes. I'm not sure this is going to be useful to read, so I think I'll skip over that. This I might want to read about because I think there are the routers that will be used during the test are MX series routers. Starting in Junos OS release 14.2, you can configure an enhanced link aggregation group, LAG, on MX series routers. When you associate a physical interface with an aggregated Ethernet interface, The physical child links are also associated with the parent aggregated Ethernet interface to form a leg. In the absence of enhanced leg support, one child next hop is created for each member link of an aggregated Ethernet interface for each VLAN interface. For example, an aggregate next hop for an aggregated Ethernet interface with 16 member links leads to the installation of 17 next hops per VLAN created. Thus, the number of next hops supported on the routers with aggregated Ethernet interfaces is significantly reduced. With the enhanced leg support, when the edit chassis network services enhanced IP statement is configured, child next hops are not created for member links, and as a result, a higher number of next hops can be supported. Note that the enhanced leg feature is only supported when the router's network services is set to operate in the enhanced IP mode. This feature is not supported when the router's network services is set to operate in the enhanced Ethernet mode. Enhanced leg support on, okay, so we don't need to read about that. So I don't think this is necessary to read about either. Yeah, it's just a lot of things. So yeah, let's just go through. Yeah, there's just a lot that's unrelated to, I think, what will be on the test. LACP is going to be on there, but I think just kind of the basic configuration for yeah, here we go. So if we can get like an example or a lab or something, I think that will be well worth the time. But reading about every little aspect of aggregated Ethernet interfaces, especially for device types that won't be on the test, it's definitely not going to be a good use of time. So let's see if there's an example. Oh, looks like there is not. So yeah, it's just about okay, so here's link protection. So I wonder if that's what they mean by fault detection. You can configure link protection for aggregated Ethernet interfaces to provide QoS on the links during operation. On aggregated Ethernet interfaces, you designate a primary and backup support link protection. Egress traffic passes only through the designated primary link. This includes transit traffic and locally generated traffic on the router or switch. When the primary link fails, traffic is routed through the backup link. Because some traffic loss is unavoidable, egress traffic is not automatically routed back to the primary link when the primary link is reestablished. Instead, you manually control the traffic. You manually control when traffic should be diverted back to the primary link from the designated backup link. All right. On aggregated Ethernet devices, you designate a primary and backup link to support link protection. Egress traffic passes only through the designated primary link. This includes transit traffic and locally generated traffic on the router or switch. When the primary link fails, traffic is routed through the backup link. Because some traffic loss is unavoidable, egress traffic is not automatically routed back to the primary link when the primary link is reestablished. Instead, you manually control when traffic should be diverted back to the primary link from the designated backup link. To manually control when the traffic should be diverted back to the primary link from the designated backup link, enter the following operational command. Request interface revert. Okay. All right, so yep, here's the, yeah, we can see how they're both for AE0, 802.3 AD, so they're gonna be belonging to a port channel. So edit interfaces, yep. So let's try putting that in. And we don't have those interfaces hooked up, but we can make configuration changes like that, even though the configuration is down. So let's do edit interfaces, AE0, set aggregated ether options. Take a look at the help on that. Take a look at some of the options we got. So we got all sorts of options. Let's see what the help says for link speed or link protection. Enable link protection mode. All right. So we're going to make interfaces 8 and 9 a part of this aggregated Ethernet interface AE0. Okay, so it looks like primary and backup must be configured to use link protection. So it looks like their example that they gave us here did not work. I don't think I'm going to downvote this because it could be dependent on whatever version they're using. But let's see if we can add link protection. So I don't see how you would add link protection. And as far as I understood, link protection was being added to the AE0 under aggregated ether options. Oh, okay. So it looks like link protection. Oh, it looks like I have two primaries. I accidentally made GE009 a primary as well, but that's meant to be a backup. Yeah, so that makes sense. You can't have link protection where it will fail over to a backup link if you didn't define the backup link. There we go. So configuration check succeeds. This is all you need to configure aggregated Ethernet link protection. So it looks like my volume cut out again. I do have fresh batteries in here, at least I thought I did. So I don't know why it would have cut out. I don't know if it's giving me inaccurate readouts. It's just not, it's saying that I don't have batteries when I do, or what the issue is, but I apologize for the audio cutting out there. This is, I think, the best audio solution I've had so far, but it's just not reliable enough unless I can get a special kind of old school USB cable that I don't currently have. And even then, I don't even know if you can get power over it. But I'm going to keep going and just get these lab devices ready to go for the configuration example. And then once that is good to go, in the next video, I'll be completing all the configuration. So kind of nothing to see in this video anyways, just set up for the next video where I'll be actually going through the configuration. Yep, and Junipers take a really long time to boot up, unfortunately. So I think I'm just going to do this between videos. Again, sorry for my audio cutting out. I'm hoping there's a better solution I can come up with for this. But until next time, thanks for watching. I'll see you in the next video.